Okay, welcome everybody. We'll continue in our UOP stakeholder meeting and stakeholder program training. And today's topic is the architecture and special focus on front end. And the surprise, nobody from Product Hub or Framework will give you this talk, but Tomáš Čotík, head of technology of OCN, will take this part and invite you with this presentation. So its next presentation will be focused more on server side and on uCloud, and we will continue in the program as you have in your tasks. So no more talks, let's start.
Okay, thank you. Maybe one correction, server side will be today.
I'm sorry.
So
Okay.
the architecture topic is split into two open sessions. Today it will be about general features of UIF architecture, front end and server, and the next open session in 2 weeks will be about cloud and business territory. So I will start with the architecture. This picture should be well known to you. What does this picture tell us? That if we want to build a system, the UIF architecture provides you such features and support that you need to develop just these green use cases. That means that the implementation for you is consists of implementation of the front-end use cases and application logic on the back end. Everything else is provided by UIF, and today I will explain you how it is provided and how it is supported. General introduction to architecture and UIF, it was in the last open session in December, so I will not repeat. I will go to more details. Sometimes it will be technical, but I think that this level of detail that will be presented today should be known to everyone. Everyone should know some basic features of UIF architecture. So I will start with definition of application, then the decomposition to sub-application, some facts about sub-applications, then I will explain the application structure, application workspace, and runtime mode. So that's the part of the architecture. Then there will be front end, the UU5, and application server. So let's start with, sorry, some mistake here. Let's start with the application. What is the application? Application is a set of functionalities that solves customers' requirements, customer needs. The application should meet or has to meet all the requirements on standard quality of delivery of Unicorn. The application has to meet all the quality, quantity, time, and budget of the project, all these criteria. But to solve implementation of this application, you have to do some thinking, you have to do some work, you have to split the whole application in some manageable parts. Because if you will give the team just build this application, they will do nothing. So there is some system how to decompose the application into small pieces in the way that it's effectively manageable and we are able to deliver the system in the QQTB. And this is the example. The first level of the composition is the composition of application into several sub-applications. Then the sub-application implements business use cases, and the implementation of the business use case is implementation of the front end and of the application server. So that's the basic picture, and I think everyone has to understand this picture because it's connected to the organization structure, to the structure of the project team. So for every layer there is a different responsibility. Architect is responsible for the designing of the sub-applications. Analyst is responsible for the business use case. Designers and developers, they are working on these use cases at the bottom. There is also impact on the organizational structure, like what is responsibility of the core team and what is responsibility of software factory. So these elements of the architecture has to be understandable to everyone. One more comment, this presentation is more oriented from the unicorn system point of view. So for example, here is a core team, but in product hub or in other parts of the organization that are implementing applications. It can be a little bit different.
May I have small comments?
Yeah.
Well, that maybe it's very important to tell that application can consist from another applications and so on, but sub-application is something like end level.
Yeah. I will come to that. There are few examples of architecture of our solutions. So this is example of Libera. And you can see that it's not just one or two sub-applications, but there is, for example, 10 sub-applications. You can see that there are sub-applications which are implemented that were built by the Libera project, but there are also sub-applications built or taken as an existing sub-applications. Similar example is RSC2. This is just a concept which is being prepared for RSC organizations. Hopefully it will be a product that will be deployed to different RSC across Europe. The yellow sub-applications are the sub-application that has to be built by the project. The blue sub-applications are already existing sub-applications and will help to make the whole solution. So you can see that there is really a lot of already existing functionality that will be included in this project. By the way, this just to explain you what is the responsibility of each sub-application is that the RSC system is responsible for some services provided for the whole Europe. It relates to security of the electrical grid of the whole Europe. So it receives models from all TSOs in the Europe. Then it builds the whole European model, and this model is tested. There is a power flow calculated on this model, and there is a lot of analysis done on these models. So there are sub-applications, for example, grid data, which manages all the information about the model, so it knows everything about lines, transformers, and grid elements. And there are services like contingency analysis, capacity calculation, which are responsible for some analytical functions. Because the computation is really demanding, it runs for a few hours, then the computation is separated on a dedicated sub-application, which is also reflected in the whole UIF architecture. Where this comes from, the split of application into sub-applications. we can find a similar pattern in microservice architecture. The sub-application is implementation of some functionality which consists of all layers, front-end, server, and database. Typically, it can consist of all layers. And the sub-application should be designed like it will provide some complex functionality. It can depend on other sub-applications, but the standalone sub-application should make sense. There are another consequences in this box. So every sub-application is documented. Every sub-application has its own code base, its own Git repository, where it's developed, the front-end application server. There is a separate configuration of each sub-application. It's tested separately, deployed separately. So these are the features. Another point of view on sub-applications is dependencies. Because the functionality of sub-application is encapsulated, there are design principles like high cohesion and low coupling, which are depicted on these pictures. So what we would like to aim is this upper picture, where all the related functionality is concentrated in one sub-application, that we will not make mess like this. Another feature of sub-application or microservice architecture is independency of these sub-applications on each other. So if one of the sub-applications will fail, it doesn't necessarily mean that it will have impact on other sub-applications. So for example, if we have a sub-application meeting rooms, if it will fail, it doesn't mean that you cannot work with your artifacts, with your calendar and other things. It will still work, just meeting rooms will be will have outage. It is very important, for example, for maintenance, because you don't, if you want to upgrade one part of the whole application, you will update just one sub-application. You don't need to shut down the whole system. Before the microservice architecture or what we can see in our systems, which are not designed according to microservice principles, you can see it here. We have applied something like modularity, that the system consists of modules, but the difference to microservice architecture or the sub-applications is that everything is built in one workspace, everything is in one Git, and if the system is really complex, then for example the build time is really long, you have to, if you want to change functionality in one module, you have to shut down the whole application, you have to redeploy the whole application. So that's the difference, and as an extreme example of modularity of really complex system is this one, the transparency platform, which consists of hundreds of modules, and this is really nightmare.
Well, and it means actually that all these source codes are at the end on same processors and can have affect each other. And this is the really nightmare.
Yeah.
And this is what we want to.
Well, it's not really true for the system. There are two parts.
Yeah.
But it's one Git, it's one build process.
Yeah.
and the public part is deployed separately from internal part. So that's the only difference. And this will be really a hard task to redesign this system into microservice architecture, because it's really complex. There is a lot of modules, and we will have to find the solution. We will have to find the right services. Another example, much better example, is for example Inca system. It's also a product, but it's not implemented today. It's not implemented in UI architecture, and this is for the HVDC. This is system for the HVDC cables, which we have deployed, I think, 5 times. So it's used on 5 HVDC cables in UK. And the modularity of this system is prepared for the UI architecture, and we already did some analysis on that. And we will simply replace each module with sub-application, and this year we would like to start with some concept, some proof of concept of migration of the system into UI architecture and into product. So these were examples. Now look at the detail of implementation of every layer. So implementation of the user interface and business logic. So if you want to build a user interface, you have to build these, you have to implement these main elements. And for the application server, it's similar. It's not everything, but I selected just the main one. What is important here, that you really need to focus only on implementation, for example, business logic, implementation of data access objects, definition of errors, configurations, validations. Here you have to implement components, but you don't see anything about performance, security. It's everything is provided by the UIF. Another maybe more understandable view on this of the same thing is this the layer view. So we have standard 3 layers: application, server, storage, and user interface. So the interface between front end and application server is through documented API. On the application server, you have to implement business logic. That's the implementation of the functional requirement in the system. And then there is a data access object, which is used for business logic to communicate with some database engine. For us, it's object store, relation store.
Actually, we've updated the naming conventions for the code, so now API and ABL are the right terms for controller and model.
Yeah, okay.
The picture before was outdated.
Yeah.
But that one is right.
Well, and there is a human interface and interface of things, well, because it is very important to mention that these fucking things are important.
Now look at the API. The API is core interface between the front end and back end, the application logic. But that's not all. The API has a lot of other features. For example, if you want to schedule some job which will call regularly some application logic, you can use async job sub-application, and it will provide us configuration of schedule tasks. Or the async job provides also possibility to call the commands in an asynchronous way. Another component which is heavily using commands or API is a script engine, and I will talk about it later. Another possibility is to use you message broker, which is used for the asynchronous communication between sub-applications. The API can be called by other sub-applications. It will make dependency between these applications. And finally, API can be called by anyone, everyone. So that's the real power of this API. What we prohibit is that you cannot access to the application or to database in any other way than the API, because we don't want to bypass the application logic, because any such update, for example, in database, it can mean some problems for the application logic, because you will do, for example, some unexpected change, and it can mean some inconsistency in data. And this API provides a lot of features. The access to API is authorized. API runs on application server and in cloud, and that provides the application server and cloud provides some technical security. The application logic implemented on server is stateless. Stateless means that we have open doors for easy scalability. It's documented. I think you saw it many times in Bookit, the definition of data in, data out, the scenario, errors. That means it's also it is standardized, the structure of the data in DTO. It's REST JSON. You can call it in a synchronous or asynchronous way, and it's reliable. It's the part of the API is error handling. So these are also the main features of the API. The decomposition, so we know that application consists of sub-applications, and that the sub-application, if you want to implement sub-application, that it's built from user interface and business logic. From the deployment point of view, what technical components you need in cloud, where you have to deploy the sub-application, it's application server, which runs the business logic and provides the user interface for a web browser to be downloaded by the web browser. On the application server, there is a possibility to use separated performing part feature of the application server, and this is used to separate functionality with different complexity. So for example, if you have functions or services which are used by frontend, these services should be fast. It should there should be response time in below 1 second. For the long-running computations, which will run for minutes or hours, it can be separated on a dedicated hardware. So it's a purpose of separated performing part. You can define this in deployment descriptor of the sub-application. The other parts, the three parts, are data stores. So depending on the data you need to manage in the application, you can choose between object store, binary store, or relational store. The most common is the object store. It's mandatory for the configuration, and additionally you can use the binary store and relational store. If you need to support asynchronous communication, you can connect to message broker and to exchange data via messages. An example of application structure in terms of splitting definition of application server and object stores. This is an example from Libera project. So you can see that every sub-application has object store, and some of them has also binary store. I'm not sure if there is relational store. It seems there is no relational store.
Yeah,
It's here. Okay. So this is an example from Libera. Now I would like to focus on these numbers. What does it mean, this number? It's number of application workspaces. So I would like to explain what the application workspace is. So we will start with the sub-application. It provides some functionality, and what we need from this sub-application is that it is reused by different purposes or by different users. You can use it for example, for different users, for different organizations. What does it mean? What I mean by this by this multi-use, that the functionality is the same, but for example, it can be used by the same functionality can be used by several organizations. If the sub-applications should be used by several organizations, then you have to somehow separate their data sets, because they probably don't want to share data between Česká spořitelna and Komerční banka, so you have to share their data sets. And that's the purpose of the application workspace. So this functionality of sub-application is implemented in some Git, so it's always one application. It's deployed to cloud, and then the sub-application has several application workspaces. Every application workspace belongs to a different user organization. Simply it has a separated data set, separated configuration. There is also an application server instance. It's for the management, for the licensing, for the management of owners of the sub-applications. So that the reason is that we don't have all the workspaces on one heap, but we can, for example, split workspaces into some groups according to the purpose of these workspaces, to some common properties of these data sets. But I just described one point of view on application workspaces. There is a separation of data sets, but there can be a lot of motivations.
Could you please return back? I'll just make a small comment. Well, as a general, it was, I think that you said it really perfect. I appreciate it. But as a general, I think it's also very good for you to know the right abstract description, which is very important. It means that each application workspace generate something or is connected somehow to some abstract group of involved users. Some of them is, for example, owner, who represents the owner, but some of them are like standard users of this application, or authorities of this application, or operators, or some executive in these applications, and so on. But as a general, this involved group of users is different for each application workspace. Well, and these application workspaces share the same code and same processors and hardware and infrastructure efforts. And it means that sometimes could happen that between these application workspaces is a group which behavior it's a little bit different than others, and it means that, for example, these groups collect to itself so many resources and so on, that this is the reason why we need to put these groups of virtual users to separate infrastructure. It means that we create for them a separate server instance. Well, this is the abstract. How is it like, from the top level? And of course, Tomáš can give you several good examples. Well, and it could be use this idea also such a different way in some special occasion, like it was, for example, in Libera. But it is like next level of knowledge. Well.
Thank you. So yeah, there can be different reasons why to define application workspace. The separation of data sets, separation of user groups, users of this data set, separation of configuration of user access rights. That's a common reason why to define application workspace. But there can be other possibilities, like you need to separate license owners, you need to have different configuration. You can do that, for example, for the performance optimization, like it was on Libera, or it's also the application workspace. It's also a unit which can be, which data can be exported and then imported as a whole. So the examples of the application workspaces is, for example, meeting rooms, sub-application. There is application workspace is the location where we have some meeting rooms. It can be, from Unicorn perspective, it can be the whole data center, but it can be also a different floor, for example, on this premises in Classic. For Libera, the application workspace consists data for one business, I hope it's one business day, which is calculated by the sub-application. There is a reason of performance, and there is also use the dump and restore, that it's calculated and it's exported, stored somewhere else, and the resources is free to be used by a calculation for the next business day. Another example is, for example, is that RSC, that the workspace can be grid model. What was already told by Vladimir is the management of access rights. There is a special feature in application workspace, and it's important to understand how application workspace authorizes access to the data. So the access rights has to solve this simple assignment. You have to define access rights for the user, that the user can access the data, and that the user can run some functionality in this data. So you have to define the relation between user, data, and functionality. And the application workspace provides functionality that you can configure profiles. Profile is a group of use cases, because if we would need to define all the permissions in a way that we will define every relation between every user, every use case, and every row in the database, then it will be a mess. It will be millions of rows in a database, so we have to somehow optimize this task. And the optimization is that we will create a group of use cases, which is called profile. Profile groups some functionality which is available to users which are cast to this profile. Also, the users can be grouped to some groups, but this is not provided directly by the application workspace, but for the grouping users and for some more complex evaluation of access rights, you will need the business territory which will implement the evaluation of access rights according to the organization structure, to the defined groups of users. So the application workspace provides only mapping between profiles and identities users. And what about data? User who is cast to a profile in one workspace has access to all data in this workspace. This is standard functionality of UIF. If you need any finest, more granular access rights, if you need to control access to every object in your database, then you have to implement it in your business logic. But it can be, or it's usually it's enough that we will leave the authorization just on the application workspace functionality. Because if the application workspace maintains some set of data which relates together, for example the meeting rooms, then you can access any meeting room in that workspace. You don't need to distinguish whether the user A has access only to room A and B, and user B has access to room C and D. So in this example, everyone has access to all rooms. So everyone can book any room in this workspace, and that's expected behavior of the application workspace. That should be a standard. But if you need something different, it's possible to implement it in the business logic.
But it is very important to tell to our colleague that there is a lot of patterns that are prepared for that. You know, there are some logical standards which can be like reused also. Well, there are some like application types and application type profile and so on and so on. And really strong added value is that you can combine all these.
Yeah, and that will be next session. Next open session will focus on business territory, and it will add this dimension of managing users in the business territory and integration of the business territory with
and also Tomáši, is very important to tell to our colleagues that if you go to the slide up once more, there is something. This slide is like didn't show the important things that you can assign also, like like in front of identity use case by the system. Well, and it means that application could be like friendly connected to another application and believe to this another application to use the use case without the rights which are belongs from your identity. Well, and also it's possible combined. It is also a little bit more difficult for maybe this lesson, but I think it's important to mention it because if you will start to use this architecture and you will try to do things which you are normally doing, well, that you will find this problem and you will ask for it and you will try to solve it such a way. And I just want to inform you that if you will come to this level, don't hesitate to ask and we will give you another advice. Yeah,
that's that alternative to this scenario. It's not related to end users, but it will build some trust between two sub-applications.
But not sub-application, but also between, for example, workspaces.
Yeah. And this is useful, for example, for this kind of integration. Yeah. For the asynchronous communication between sub-applications or any kind of
that you
integration.
can simply say, I believe in this workspace, well, to use that use case from that workspace of this sub-application.
Yeah. But it's also important to tell that if a user is accessing sub-application A, and the sub-application A calls a functionality from sub-application B, you can propagate the identity, the original end-user identity through sub-applications, through the chain of calls, to the nested sub-application. So the nested calls will always know what is the originating user. That's also supported. But for the sub-application integration, it will be mostly common approach to do the signing of the requests, and it will be fast.
But still there will be, you know, something like a application server user test for access. Well, by the way, we mentioned here with David that picture that you show us now is excellent, and we have to add it to the book because
I just wrote a comment to the book extracts picture.
yeah, it's a nice one. Thanks for that.
Yeah, and I think the last feature I have prepared about applications is runtime mode, and the runtime mode is used to control provided functionality by sub-application. What is generally available and what is restricted. It's used for special maintenance tasks like a deployment of the new application or data management or some upgrades, migrations. So you can switch the sub-application. You can switch the sub-application to restrictive mode. I'm not sure if there wasn't some change in naming of these modes, but you can switch the sub-application in restrictive mode, and then it cannot be used by standard users. It's allowed, it's available only for users with special privileges. And that the reason is to do some maintenance tasks. You can switch the application into restrictive mode either in application server instance level or application workspace level. So that's for the maintenance. And the summary of architecture of UU application and sub-applications is that sub-application provides some functionalities. Every sub-application should have an owner. Sub-application manages persistent data. The access to data is authorized, and sub-application should follow some architectural rules, design rules like high cohesion, low coupling, and the sub-application is a unit of deployment to UU Cloud. So that's a summary of the features, and now I will add some more technical view on application architecture. I will go back, you have already seen this slide, and what does it mean? I already told that this is something, the yellow boxes is something what you have to implement, but the UIF provides a lot of features, a lot of existing functionality to provide some non-functional requirements, to meet the non-functional requirements, to provide some additional functionality to you. And this is some overview of features and functionalities provided to you when you need to implement sub-applications. The blue boxes are features of each layer. So if we look at the application server provides you with login, authentication, authorization, caching. The same for front-end. There is a prepared functionality for multi-language configuration. You are able to call servers. There are features like nesting, dynamic rendering. So these are all features provided by each layer. For the front-end, there is a predefined set of components. There is really huge. It's really a huge set of components. You will see some examples later. For the application server, there are the data stores that I have mentioned, the possibility to call commands in an asynchronous way. There is script engine. There is, for example, a central log store of audit log. recorded in your sub-applications. And finally, there is a set of core services. The first two core services relates to security. It's about OIDC and identity management. Then there are some supporting, like if you want to generate a PDF, if you want to provide a full text search in your application, there are prepared services for that. Then there are a set of services which are responsible for management of everything what we build. So it's not somewhere in Git, but it's registered in the product catalog, component catalog. If we build a system and we need to publish it somewhere in the binaries, we can store it in application repository. It's used, for example, for libraries which are shared across sub-applications. And finally, there is a application library registry, which is used by front-end. You will see examples later. And the last set of core services is related to the application pipeline.
Actually, this picture is pretty good, but it's very important to tell that many times it is like that, for example, object store, it is like service, and also this service is come together with some server library which you import to your like source code.
Resistance.
Exactly right. And it means that there are a lot of other things like this, that for example, you can have completely work with attachments.
Yeah.
You can have dynamic component content, well, and so on and so on. There will be a lot of things.
This is just space is limited.
Well, of course. Well, and but this is what I want to tell to our colleague, that we are working on that, and because it is focused and fulfill the standards of all the architecture, that it means that it is possible completely share and reuse anywhere, and it will be documented. There will be our colleagues, like our developers and designers, trained on Top Gun and so on. And this is what we need to do, what we need to do, and how we need to work. Well, the effectiveness of this process will be amazing, but we have to survive.
Next view is the technology view. You can see the main technologies used in every layer. So just an examples for the user interface, it's React. For the API, it's JSON. Application service supported by actually 4 technologies, but just 2 of them are the main preferred technologies, it's Java and .NET. Sorry, no JS. Persistence, the object store is implemented using MongoDB, and the cloud, the main technology is Docker. And there is a lot of other technologies. The final set of slides for the application part is about delivery and life cycle of sub-application. Again, this picture, what you have to implement when you want to build a sub-application, and now how this implementation of sub-application is supported from the process point of view. First of all, we have sub-applications which will help us to build a specification, to build a documentation of sub-applications. It starts with business request man, it's about requirements on the sub-application. Then there is a business model, documented business model of the sub-application. Then there is a detailed design documented in application model. Then there is a dev kit, which will help you to build the environment where you are able to develop everything. Then you will develop it in UIF architecture. That was the previous slide with all the features and services. Then there is a pipeline which will help you to deploy the application to the file using cloud. So that's the whole chain which supports development of sub-applications. And there is another set of services helping us to manage everything and to operate and maintain our solutions. So this is these services, sub-applications are for project management, but there are sub-applications for first-line support and second-line support. So you can see that the architecture and the UIF is not just isolated pieces of code or patterns, but from this picture you can see that UIF builds the architecture, which is the view on the architecture is very complex, and everything is connected with each other. So it's not the important message here is that these are not isolated pieces of code. These are not isolated sub-applications. But if we will define that there is something like command, then the command is used whenever it needed to be referenced. It's always command. It's about architecture. The architecture, the original reason to define the architecture is to define a vocabulary, because the architecture helps us to communicate with each other. And the same applies for these sub-applications. They all use the same vocabulary, the same definition of architecture. So that's all for the application architecture introduction, and now I will switch to front-end, to UU5, and we have prepared some demo of these main concepts of UU5. So I'd like to invite Radek Dolej and Ivo Milota, and they will show you these main concepts of front-end of UIF.
Okay, thank you. Hello, I have prepared some few demos or few examples about this concept, which I think, I believe, they are most important of U5, because U5 is not just a library of component, but it's also a system for building the whole front end. The most important, from my point of view, and most cool concept of U5 is dynamic loading of component, where you can use any component in any application you want. Yeah, for example, this component. This is a component from business territory. It's a little teaser for next open session. I will not talk about the business territory. I just want to show you this component because it looks nice. It's the activity of some artifact or activities of some artifact. And I want to take this component and put this component to this application. This is WebKit, so I can edit this web. I will delete my previous tries, and I will take this component just like this. I will switch to English, and I will just copy component. Yeah, and here in this application knows nothing about that business territory. There is no dependency between this WebKit and the business territory itself, or that component from the business territory. I can just put here the insert code and OK, and now I have this component from that application, the business territory application, here in this application, and it's working. And everyone who has tried to see these activities on this artifact in business territory can see this component here in this application. Yeah, and it's not just like that. You can see that the same application, same component. You can see the difference between these components. Yeah, here this component is in home application in business territory. So you can see there is no information about the territory and so on. But here, the component itself know that the component is not in one application, it's some different application. So this component change the how it looks like, and here you can see that the component is from this artifact AGL workshop, and here is the territory unicorn solution and other information. Yeah, and it's done just by this component itself, not by this application or the business territory application. Just pattern how to implement this component, and it's provided by U5. I can show you some other example. I have some workspace of this is some proof of concept for Nordkap from Tomáš Tetík, and this application, or this is just small demo application. It's
Maybe I will tell you a story to
Yeah,
this
that's
example. This was prepared last year, in January last year, for the RFP for Nordic region for RSC. So we have prepared some use cases, and one functionality was remedial action coordination. And last year, if you can switch to the application to remedial actions, there are some remedial actions done on the European grid, and if you want to do some change in the model, then the involved or affected TSOs has to agree on this change. So we took that there was a component, some forum or discussion, so we took this component and used it in this example. So you can see this discussion, and that was the purpose of that was that TSOs, operators, can communicate and to find the solution for this model. But today, but this is just pure communication. That there is finally we would need something like that. They will approve the change, but this is not possible by discussion. But today we have a business territory, we have activities, and we can change this component to the business territory activities, and Radek will show you.
Yeah,
Yes.
this is the source code responsible for this page. So I can just replace this discussion forum with this component. This is component view territory activity bricks detail, and let's see what happens.
Are you kidding?
I'm completely sure. Yeah, and here you can see we have the activity detail that we can set the task. You can even use the functionality of this component. Like if I want to add some new solver of this activity, I can use the forms of this component. But as you can see, this form it's not shown here in this place where the component is. It's used. It's using the modal window of the page, and all I have to done is that I just use the U5, and that's all, nothing else. I just use the U5 in this application and in this application, in this component, and that's what I need to just put this component to this application, and that's all.
So
Yeah.
something what was just simple chat was replaced by an activity list where you can really approve or disagree with the proposed solution of remedial actions.
Well,
Something. Yeah. Okay. So next cool feature, next concept, important concept of a U5 component. It's I choose the editation mode of component because it's also important. If you look at this page created in this web, I have this component here. This is the chart. It's not good presentation without chart, so I put chart here, and I want to edit this component. Yeah, so if I want to edit this component, I just choose the edit button, and as you can see here, I have some form where I can change the data and behavior and the component itself, and I can change everything. I can add some more value to Apple, and I can decrease maybe ATC. It's not just one is enough. Maybe Samsung it's also 7 it's enough. And I can change the, as you can see, I can change this pie here. Yeah, and again this form in this modal window, it's not the implementation from the application, the WebKit. It's just it's part of this component that I used in WebKit. So I can use this component anywhere, and everywhere I can use this component with some, of course, this dynamic component content. We will talk about it someday later. I can use this editable mode of any component which is implementing it. So
maybe can you put it back?
Yeah.
And run the edit mode again.
This?
Yes, this one. Show the data view, for example. Yes, you can see this JSON edit style. It's not so much user friendly, but it's just a matter of money and time you want to invest into one single component. But if we decide that we will have to do something much more sophisticated for common users, like some editable data table or something, at the moment with this new version of the component, all applications run in the new cloud. At the same moment, we'll have the new editation without any compilation, redeployment. It will be just there. Next minute we deploy. Of course, on-premise applications will lack of this feature, but this is dynamic component loading, and it means that we can improve many parts of the user interface independently, and all the applications will benefit from it. Yeah. And they will not need to invest any extra money. Just keep the architecture pure, and if you keep all the conditions you have to, then this will work.
Of course, it needs to be every time perfectly tested, very safely implemented and so on, but it's a huge added value. And if they have these components and these solutions like on-premise, they can compete with that because it's low. Then this is the reason why we want to have everything in the architecture. If some of our users try to force us to make it different, we have to have force and guns to explain them that it is really big error or big mistakes to force us to do it like that because it's stupid. This is the architecture.
Okay. Next pattern or next concept is, for example, color schema. You can specify the color schema for each component. So there is some predefined color schemes, and if you look at any application and you are using any component, you can just change the color scheme, and every component will change the color according to, I just selected the gray, for example. Every component change the colors, and these colors are selected the way that you can, the components looks correctly. So you have the white color of text on the dark background and so on. You can also implement your own color scheme. So if you need the application with different colors than these default values, you can just specify some set of colors, and you can add your color scheme to your application, and you can use it anywhere like the other color scheme. So multi-languagism, it's also important concept. It's you can see it in any application. You can change the language in any application, and all component will change the language. If I change the language here on my website, you can see that this component is not from this application. I just use it from another application, and this application also changed the language with this button. So it's in one environment, and if I change the language in this environment, it change language in the component. But it's not only that I change language. I can change much more. I can change for different languages. I can render the different components. So, for example, if you have some some data related to language, for example, postal code or something like that, you can render the completely different set of components for any language you want.
Okay. Radku, it means that generally U5, it isn't another React. U5, it's not another HTML. U5 is like human interface environment based on HTML5 browsers developed mainly on React technologies. Well, that's it. This is the definition. But it's completely different things, completely different added value, and you have to understand the standard concept of that, and if you will, you can achieve really excellent added value. You will be very fast, and you can create a lot of things which no one else simply will create, because it is not so simple to do it like you see. Well.
Yeah, and about the languages, there is one more.
For example, Radku, please, just try. Anywhere here, you can, for example, write a comment to this application, to this activity or something like that, and try to put to this comment this chart as you show us. Well, let's copy this chart, like copy component. Well, copy. Well, open anywhere that here in this activity. Here in this activity, this? You can go to the detail. Well, and here add this chart to the detail, like this. Well. No. Well, something happened, and what? I don't know if it is like that. You have it in you know. Well. Yeah, I understand, because this is I understand, because it's a JSON. This was not correct. This is not correct U5 string.
Sorry.
But never mind. Well, that forget it. But I don't know why it isn't like that. But normally it need to work. But I don't know why.
I think there's some different problem, because this was valid U5 string, it's escaped.
Yeah?
And the JSON is in the JSON, is U5 JSON, so it should work.
Never mind. No problem.
Something wrong. Something else is wrong. But
Something else is wrong, but normally it should work. It should work.
we'll find out.
In this concept, it's also besides this LSC items, it is, for example, solved how to load these language sensitive items from the server, so you can have your labels on the server. For example, I saw some solution that the labels are part of database, so you can handle. It's already prepared for it. Yeah, and also the dev kit, so our tools are prepared and compatible with this solution, because you can export whole language, whole labels from your application directly to some I don't know, Excel. Then you can let it translate it to a new language or just some language corrections. Then you can download it back to your application. Yeah, and it's provided by UDevKit, so everything is connected. Another concept, important concept, is screen size or responsivity. This concept, it's not just about that you can, as you can see in some other libraries, that it's not about putting component to the page, not next to each other, but in separate order. It's also about that you can use the flexbox, for example. You can use the screen size, so you can render completely different component for mobile phone or for the large screen. You can see example, for example, very popular application ChargeUp. You can see responsivity here. Yeah, this is the desktop. Yeah, no, this is the web. I go to application. This is the application. Yeah. This is desktop, and if I go to my cell phone, yeah, you can see completely different, not completely different, I can see different content. Yeah. For example, on my mobile phone, here is the button that I want to see the map. Yeah, this button has no sense in this view. Yeah, because I have enough space here. So this is, again, it's handled by U5. Another concept, nesting level. This concept provided by U5, it's about that each component should be able to adapt the space where it's rendered. So if this component has enough space, it can be shown on the whole. But if there is, for example, that I want to put this component in some line, it should change the way how it's rendered. So I can show you the example with this component. Yeah, I can copy this component. I will delete it, and here I can write some text or some paragraph. This is a paragraph, so it's just some text, and I want to put this component here to this line. So as you can see, this component is just in line this text. Yeah, this text can continue here, and this component doesn't render and doesn't take lots of space here, because it can broke whole content. And if I click on this link, yeah, it navigates me to the new window with application which is just for this purpose. It's a +4U Go application where I can show any component on the whole page, and here is example how nesting level is done. Yeah. Any other important concept is authentication. You don't have to solve authentication for your calling when you want to call the server, because it's handled by U5 and the other libraries from Unicorn Application Framework. Routing, for example, you can see on any application that it's important. You know that it's important to change this route, so users can send this URL to each other and store it to this shortcuts. Yeah, but it's not only about the routing. That if you change the route and you want, this is some, for example, I want to go another page and I want to go back. This router can also provide and protect you from leaving the page before you want. Yeah, for example, here I can choose this form, and if I want to leave this page, it can help me that it's something in this page is not stored. Are you sure you want to leave? Yeah, or if I want to leave here, yeah, it asks me. This is the functionality from the router itself. Yeah? It doesn't have to be implemented in each use case. Yeah, it's just some behavior of router. So, and yeah, and some another examples from Lancelot. I want to ask Ivo Milota. He wants to show us some nice component from Lancelot.
Hello. Sorry, so I will show you some examples from Lancelot. It's product developed for energy markets companies, and I wanted me to show you some like complex forms. So we have trade management in here, functionality. We can see a list of commodity trades in here. I can show you a list of some commodities. This form is concepted to show hundreds, thousands of trades. There really can be a lot of entities, so we have decided to have a filter to pre-filter information before we receive them from server. Okay, Radek spoke about responsibility. This application is responsible. I just wanted to show you one special example of responsibility. We have decided that we are not able to design these difficult forms for mobile phones, so we have decided to implement one screen that is presented on small screen, so that we have a time to solve this problem. And I'll show you creating of new trade. This screen is about dependencies and a lot of dependencies between each fields in this form. If I try to fill, these are especially selects, so there are a lot of selects, as you can see, and many of these selects are not filled in, no data are presented. I have to start left top and start filling the form, so I will select gas, I will select direction, so I will select by. Grand point was pre-selected because there is only one option, so I already filled this information. When I changed to sell, it was changed to exit in here. For buy we have entry. I will select market. When I select OTC market, currency is pre-filled because we have default currency set up. When I select broker, market, several types of fees are pre-filled because we have some fees connected with this type of market. I can select counterparty, I can select portfolio, and as you can see, some informations are pre-filled based on what I select in previous steps. So I can simply go through this form and pre-fill it the way the dependencies are specified. When I change counterparty, if there are fields dependent on this counterparty, they will also change. We can select, for example, quarter, product in here. We will select delivery from to, and when I select January, I automatically recalculate January to a quarter because I know that quarter is 3 months, and I specify delivery from to this selected quarter. So this is about form.
Well, but I think that it's very important to tell something. Well, that it's nice and beautiful, it's perfect, and it's very heavy work. But to do forms like this, it's a nightmare if you try to do it as you are usually doing it. But if you use these strategies, it will be like quite not simple, but quite well. And it means that for these forms, you have to create some unusual components, which is like up. There is some state properties or values, attributes. Well, and with all these functionalities in the form, you just call some interface on some routines of these unusual components. Every time follow all these rules, which are very complicated, as you saw here, and after you have a like end state of possible form, which you after simply display. Well, and this is how it is working without any error. And Ivo can here make and put to every field everything, and it will work. Well, but it is not normal.
Well, like if I change balance zone, this means every field in this form will be changed, including fees, because I don't have specified market and fees are specific for market. So I'm asked, okay, all fees will be deleted. Do you really want to continue? No, I don't, and I'm here with the previous information.
But this is excellent work, really. I appreciate it. Excellent work. Perfect. But the reason how it could be like that is that you use proper strategy how to do it. And this is what will be also another special part of training, how to create forms like this. Well, it will be our focus to put it to the Top Gun, Unicorn University, college students, well, and so on. That everyone who is like asked to do these forms or forms like this have to know it, because if not, it is like swimming across the ocean. Well, perfect.
Thank you.
Okay, thank you, Radek. And I will switch to the presentation.
It's
and
also
continue.
nice that you don't forget this green button. They have to tell you this story about this green button in the right side. Well, that our architecture doesn't work with it. Without it, it for 2 years it is like untouchable.
Sure, it's 11 months.
I will continue with UU5 topics. Everything what you have seen, all the concepts and components, everything is documented. So here are the links. I will not go there, so everyone can open it. What is really exclusive from this, Vladimir already summarized that it's a consistent view. So all the features are supported consistently across the components, if it makes sense. It's a complex solution. It's efficient for developers to build the applications. It's secure. Everything is standardized, and there is a support for all these features and components. So that's what we have with UU5, and as already Vladimir mentioned, there are solutions on the web that you can use some libraries, but it is far from, it's uncomparable with this UU5 from different point of views. So if you open any of these libraries, there is a limited number of components, not in this quantity as we have in UU5. If you want to mix all these components together in one application, it will be nightmare for you. And there is limited concepts implemented. So something what we have, all these concepts in our components, it's something exclusive, and it's not comparable to any existing library. On the other hand, there are some usable components, so sometimes we will take a component from these libraries and we will wrap it to UU5, and we will add all the missing features, concepts and functionalities to this component, and we are using it. So there is a lot of such components that we reuse from the existing functionality. But always we have to wrap it, because you have seen a lot of concepts, a lot of really useful features, and this is definitely, this is not provided by the existing libraries on the web. Then there is a few examples. I think it's not needed to describe them, but I would like to highlight one important thing. We do systems mostly for our customers, which are used by authorized users. And in energy domain, we have already implemented a lot of systems like Tere, Damas, we will implement RSC, there's green certificates, OPC, STL. Everything is used by authorized users, by TSO operators, or users like that. There is one example we are working on right now. We have prepared a proof of concept for the user interface of transparency platform. That was the nightmare of the hundreds of modules. So we started the migration to UIF of this system, and we started with user interface. So there is a proof of concept. However, the graphical design wasn't prepared by us, but it was prepared by our customer. So we had no influence on that, and originally the new front end was delivered by a different company, but because they were able just to prepare these designs, and they implemented few screens, and they were not able to build the whole solution. So so he asked us to prepare a proof of concept to build this website in our technology. So there is an example of application which is not used by authorized users, but this application will be publicly available. So it is the purpose of this system is to publish the data. So if you don't like something in this design, it's because it's not prepared by us. But what I would like to show you is that UU5 is not usable only for applications which are designed by us, but it's also usable for applications which are designed by different companies. But I think this won't be a common approach. The common approach would be that our department or Big Design will prepare the design of this application. So there is some standard features, charts, tables. Another important thing about these examples is these are the examples from energy domain. But do you see something that is common for all these examples? That if we will integrate components from these different solutions into one application, that it will still make sense? Today we are not in this perfect state because every application is designed individually and there are some small differences. And today there is a problem that we have difficulties to share the use cases between these applications. But that's something what we are also working on, how to unify these applications, that they will behave the same way, and that it will be visible that it's system from Unicode, because it will follow the same rules, the same layout, the same behavior. And now I would like to ask Vladimír Kovář Jr. That will show you what we are working on.
Mám pokračovat dál v té prezentaci? Jo. So, one of my competency in Unicorn is user experience, as you know, one of part of user experience is graphic user interface. But that's not what I want to talk about today. I want to talk about graphic design system, which we are using when we are building some new solution or some graphic user interface. So, why we need something like a graphic design system? Of course, if you are doing or if you are developing some separate products like websites or small applications in some small companies, you may not need some robust graphic design system, but when you are developing some products in framework, or you are working on products which are mainly used in some bundle, for example our UP products, it's absolutely necessary to use some unified graphic design system. Another question maybe why we don't use any existing solution. It's simply answer because it's the same as with UUP methodology, which is directly written and connected with our processes in company. It's the same for EU graphic design system, which is connected with UUP framework. We decided to make a separate product, which is called EU graphic design system, and there is its vision. Use of graphic design system will ensure compatibility of graphics, user interactions, and information structure design across the applications and components in the UUP framework, and their reusability. The reusability is the important word here. Productive graphic design system is a set of patterns, elements, and other guidelines which will allow designers, teams, and suppliers to design, realize, and develop from basic components to complex ones, and also to develop, design, and realize a set of components and GUI for roles and applications in the application framework and everything in standardized process. There are a few parts of graphic design system. It's like description of graphic attributes of components, screen sizes, nesting levels, as Radek mentioned before, color system, typography, and iconography. So this is the vision, and what is our current state? So many successful products and projects have been developed using U5 libraries and current graphic design system. So we definitely can say that our current design system is good. I'm not sure it's the best, but it's good enough. But we want to improve it, so we are hardly working on next generation. For your information, last 1.5 years we built, we designed and collected with our partners like Vision or Big Design more than 300 components. We wrote more than 400 examples, patterns, and other how-to pages and documentations, which are mainly in documentation books from U5 libraries. Now we have something about 300 sketch files, which is the sourcing files for the graphic, with more than 40,000 screens. It's quite a lot of screen. There are few examples of those patterns. For example, how to handle with the information with component block layout on the right side. The left top corner is a pattern about context information from EU business territory, and the last one is how to handle with inline mode in UDCC. So that was current state, and what is in the next generation? One of the main differences is that we make U graphic design system as a product with everything, with its own documentation, and everything will be here, and from this documentation it will be coded to another books. So it's made from the 3 parts: foundations, bases, and components. The first one is most about learning graphic design system and how it works and what knowledge you should have to use it and how. And another one is all the basis of the information of the system you have to work with, from colors to layout and structure of components, structure of roads, and composed components. And finally, information about components and how we have to design them for in proper way. So, what are our main goals for next generation? One of the most important goal is that we want to one of the most important goals is to be able to create a theme per graphic user interface, theme per application workspace. It means that, for example, Komerční banka or products, Libera or something like that, should have different typography, different colors, and different things like that. But it's a quite long way. We have to solve many other problems, which is, for example, consistency. But it's not only consistency in the visual design, it's also consistency across the whole UX. For example, where are buttons in the form, or which color is primarily how looks forms, modals, and other components, and how looks main navigation, or how looks navigation if the application is connected to business territory, because in short time each application will be connected to some territory. And those things will be mainly done by revision of those particular parts, which is mentioned on the screen. It's typography and iconography, colors, grids and layouts, and many others. And another goal is to simplify GUI development. It means more examples, more patterns. We expected that we will have first version of the graphic design system by the end of the second quarter, but it's a lot of work. For now, we should.
But on the other hand, we will implement intermediate outputs during the time, so we will not wait till the end.
Okay.
Everything which is clear will be directly implemented into applications.
So there is one preview of new concept of +4U5 layout. There are still a few things to discuss, but let's look on it. The main change is on the left side, which is from the top to the bottom, and it's completely resizable, like you've seen in Lancelot Thin Client. And the content of the left side is built completely from the components, and which will be should be shared across the applications, because it will use the same layout. So it is one of the advantages. And there is also some rules which define places for components which are in each application, or which have to be in the application, like about pages, the bottom left, and bottom right, the health or knowledge base shortcut, and on the top menu of logo of the product. Another part is top. On the right side is +4U button. On the left side is back button and context information to the business territory. So you can see in which territory you are, and which organization unit you are, and the object which you are looking for. And the last part which I want to show you is a new system for typography, because typography is one of our current pain points, so we don't use it properly. We have to place text components on the screen with right way. It means if you are working on components which are which are using content, means some text which is semantic, which has semantic meaning for content, you simply cannot use main title, because if you do that, after that it doesn't work. So if this will be described it's described in the documentation, and every text styles which is here should have been mapped on the screen. We have 3 categories according its use. Story, it's mainly for components which are for writing long documents or articles. Another one is interface, which is, for example, for buttons or titles, and the last one is category exposed, which is mainly for marketing use. For example, for if you are if you want to have on your website some big sign like in component hero image, there should be different font and different sizes and completely different typography than those other two categories. This is a small preview. Sorry for the picture, but it's full screen size on the in the documentation. And there is a preview of how it looks if you are designing some components. So this is from the Lancelot, and you can see that each text which is on the screen is mapped on the linked on one of those styles from the typography styles. So this is what we are working now, and I hope next time I will show you more. Okay.
Okay, thank you. Now there is a few slides to finish this open session. Some projects, lessons learned using front end. From the point of component implementation, what we had problem with is the consistency between the design of the screens and the component features. So there were these problems. We are fixing that, and the problems is what you have to be careful about is that when the developer is looking at the design and comparing it with the UU5 component, then if there is an inconsistency, the first thing the developer will do is that will forget UU5 and will be looking for a component that will fit the requirements from the screen design. But that's of course wrong. The problem is that they are not able to ask UU5 that they do not communicate with UIF, but they have to. They have to either change the screen design that it's compatible with the UIF components features, or you have to ask UIF developers teams to improve the components, and both things are possible. We have really good experience if when we needed to improve some UU5 component. It's just about discussion, it's about communication, and it's not fixed, these components. If there is something wrong, be sure that it has to be improved, and they will improve it. But don't throw it away and don't start looking for some custom solution or your own solution. It's totally wrong way. Another thing with special attention is correct root design. You have to identify roots in your application. That's what we had a problem with. And I already mentioned the feedback to UU5 and using third-party components. If you will use that part component, then forget all the features what we have presented, and that's not possible. The last thing about UU5 is roadmap. You can find it in the documentation. So there is a special page in application framework. I will shortly show you the page. Radek, can you log in? So it's not publicly available. It's something that we have to fix.
You know that, right? You should be in UI enthusiast.
No, Ivo, there is
Ivo. Ivo is not an UI enthusiast. Right. I will check it.
So there is this page, and for every technological layer, for every area, UI5, server kit, core services, there is a roadmap where you can find out what will be implemented or what is the plan for implementation in next 2 quarters and what was in the history. So I will not go into the details now, but you can find it, and I think it should be somehow publicly available.
Tomáši, there are also some very small but very nice solutions from Unicorn College, from Marek Beránek, some management of lock of the door, or some management of some weather forecast station or something like that. Well, that because it's like communication with like things, and maybe it will be possible to, for example, give just 20 minutes to some lesson to show it well, because I think it is very very well done now. It's very simple but nice.
Yeah, today we focused on the user interface and applications. It can be
just to inform that it is here and
I will arrange it for some next session.
Well,
That's a good idea.
And of course, that there are a lot of data that you can after together with this, for example, create some components like for statistics or something like that. A lot of charts and so on.
Yeah. So finally, application server, just shortly, there is an overview of technologies. So there are 4 supported technologies. However, the last one, the Ruby, I think it won't be supported anymore. So there are no new applications being built in Ruby. So the 2 main technologies, strategic technologies for implementation of EU applications is Node.js and Java. These are some list of versions and frameworks used in every technology stack. As it was already mentioned in the architecture section, there are some common or supported applications like data store. So there are 4 types of data stores supporting services for application server, asynchronous jobs, that's for asynchronous execution of tasks on application server or some scheduled tasks. The script engine, this is very interesting component. It's it has really broader usability. There is many use cases where script engine can be used. For example, it can be used for orchestration of calls, command calls. So you can design your sub-application with some basic logic or some atomic functions, and if you need some orchestration, like in some business process, then you can use script engine to orchestrate calls across commands and to build the whole process. So if you will have a command for validations, for processing data, for sending data, and you need to build a process and to call all these commands in a proper order, you can use the script engine. There are benefits that the scripts don't need to be bundled with the application. They don't need to be deployed on your application server, and there is easier maintenance of these scripts. Another usage, important usage of scripts is customization of your sub-applications. There is a nice example for a sub-application called Booking Engine, which is used for booking of yachts in Croatia, apartments in Rudoznica. This application provides some booking functionality. However, the rules for each location is different. The rules for each products are different. Somewhere you can book only the whole week. Somewhere you can book just one bed for a night. Somewhere you can book just a 3 hours lesson in a day. And this is the customization of these are the custom validation rules, which are specific for the application workspace, and that's, for example, the case. Important case for the script engine to define these scripts, these validations, these custom validations by the script. And then the application is standard. It's the application logic is common for all these locations, for all these workspaces, but the validations are specific. And that's the way how to customize your applications per application workspace. Another usable is collecting audit logs in one place, calculating statistics, usage of your API and user interface. The last one is message broker is used for asynchronous communication. There are a few examples of fulfilling non-functional requirements. This is just for example. So if we will talk, for example, about reliability, then you can see which component will help us to fulfill reliability requirements. So that's for the reliability. The important thing about reliability is that we have validations, error handling, that there is logging and monitoring, and everything is under control. Similar to performance, so for performance it's important to have optimized the storages, to use caches, tasks with high complexity are executed in an asynchronous way, and we can collect some statistics about behavior of our application. About security, the important components are OIDC, identity management. Front-end is able to authenticate the user. Server is able to authorize all the access and to write important events to audit log. From the security point of view, there are more important interesting things. For example, that the UIF applications are compliant to OWASP application security verification standard, version 4, level 2. So we passed this list of about 300 requirements. We have defined the secure software development lifecycle. This is really a usable thing, especially for our proposals to our clients. On the other hand, we have to follow this standard in implementation of our systems. And our applications below the UIF passed successfully penetration tests done by our customers, especially the Nordic region is really sensitive on security, and the results are quite impressive because, for example, for the source code review, they don't find any issue, and they said that the quality of source code is really good. There was no critical finding. I think this is the result from the last penetration test done by MSOE. And I think that was just one major finding, which is not so complex to fix. Some lessons learned. The first thing is design. Design is really helpful because when you will do the technical design, then you are able to find all the problems before you will start implementation. That's important checkpoint for you. If you do the correct review of the design, you will find all the issues because it's visible in the design. If you don't do the design, if you will not do the review of the design, then it will be implemented, but nobody will find the issues in the code. So the next point where you are able to find some inconsistencies or issues in your design is testing, and it's very late. So the design helps us to find all the issues before the implementation, and that's really important. Other things related to design and implementation is performance, but this is nothing to do with UIF. It's just about patterns, and if it's about complexity of tasks. So if user will start some functionality and user is expecting response time below 1 second, it's not possible to generate 10,000 requests to database because it will never be processed in 1 second. So these are standard problems. Other issues or other things to improve are properly implement the backward compatibility. It's important mainly for product-like applications, and then the correct design of objects in object store and design of user access rights. I already showed the roadmap in the documentation, so this applies to application server as well. And that's everything what we have prepared for today. So thank you, Radek, Ivo, Láďa. Thank you for your attention. That's all.
Do you have some questions from this side?
One question from the internet, from Dimitro, about creating books.
Yeah.
They are already integrated into UI5 and if the teams can use that.
Yes, they are integrated in U5, but wait for the right concept. We are preparing the concept how it should be used, and don't use them till we publish this concept.
But it's coming.
It's
It will
coming.
come in the next month.
Yeah.
So just be patient.
Is that all?
That's all.
Okay, thank you so much.
Thank you.
Thank you.
Super.